going to meet on the 22nd, and so we would have started section 5.5. The nice thing about doing it at home, the hardest part about this section is remembering things, but this way you'll be looking at them. Okay, so this chapter involves realizing what real numbers are. Last chapter we did, section I should say, we did the square root of a number, which can be a irrational number. So the set of real numbers is made up of rational and irrational numbers. Rational is a number that can be written as a fraction. It's a non-repeating, uh, it could be repeating, but it's an ending decimal. Irrational is a non-repeating, non-ending decimal, like the square root of 10 or something like that. So there's another set of numbers called imaginary, and that's why these are called real. Okay, so the natural numbers used to be called the counting. It's also called the counting numbers, are the smallest set, and that's just you start counting at 1, 2, 3. Then they realize, you know what? If we don't have anything, we need to have a 0. That's the whole numbers. Then if we owe somebody something, we need negative numbers, so that's where the integers came in. And all of those are encompass the rational numbers, okay? Because they can all be written as fractions. So all of these numbers are rational. And then the irrational numbers are over here, radical 2, radical 3, anything that is not a non-ending, non-repeating decimal. So same thing here. The real numbers are made up of rational and irrational. The rational numbers are made of integers, fractions, and terminating or repeating decimals. And then integers are made up of the natural numbers, zeros, and negative integers. That's just what they're made up of. Okay, so the first property is the commutative property, and I'm sure you've heard it before. And it just means that you could change the order, that you could do A plus B, and that's going to be the same exact thing as if you did B plus A. It doesn't matter what order you add them in. And the same happens with multiplication. It's not true for subtraction and division because order matters there. So that's why these are stand out. The other one is the associative property. So it doesn't matter if you add the first two first and then add the second two, or if you multiply the first two and you're just changing the grouping, but the order has all stayed the same. Distributive, you know that one, so that if you took this A, let me just grab my pen here, which for some reason I don't have yet. You took the A and you distributed it over the parentheses, you'd get A times B, and you'd get A times C. There you go. Now the pen's working and it's crossing things out great. My computer, probably like yours, is not working that well right now. So the first property, if it's x times 9 or 9 times x, when it changes the order, that's the commutative property. That changes the order. Associative, you can check by going, okay, this goes x 3, 7, and over here it goes x 3, 7, so the order did not change. All they did was slide the parentheses. That's the associative property. And the distributive is you're going to distribute. It's the property of multiplication over addition, okay, where you're multiplying and distributing over the parentheses. So this one again, 5, 3y, 5, 3y. So all you did was change how you were multiplying, changing the grouping. That's associative. But this one, even though it has parentheses, goes 2w6, and this says 6 2w. So the order changed. They didn't just slide the parentheses. They actually changed the order, and that's why that's commutative. So this would be commutative also. And again, you're looking at, don't just think just, oh, I see parentheses, it's associative. This over here goes 7z4, and now it's 7 4z. So inside, they changed the order right here. And once you change the order, that's commutative. So this one is distributing. We did this in the last chapter. 5 times 2 is 10. But when you do 5 times radical 3, it's just 5 radical 3. Nothing goes under the radical that isn't already there, so it does not become radical 15. And then this is just distributing without the radical. 2 times x is 2x. 2 times 5 is 10. Okay, so that's all that's in that section. And so that one was an easy section.